may seem unwieldy or excessively complicated or even wrong. At first glance, they may even appear wrong or unintuitive. But you can be absolutely sure that whatever you have written is true if you are logical. Now, having said that, writing logically is not the only desirable thing, because sometimes it gets in the way. For example, if you are discussing about a mathematical concept with someone, or for example, a mathematical proof that you want to discuss with someone, you may not go through all the details of the proof with that person. What you do is that you just tell him the important points, important steps in between. That is, it will have many steps which are statements. Each statement comes from the previous statement because of some logical reason. So those are the steps. So you do not tell him all the steps. In between there are many steps. You just start with the hypothesis, you reach the conclusion in a quick succession of some steps, some intermediate results which are plausible, so that the person may be reasonably convinced. See, now you are not, this argument that you have presented is not logical because it misses some steps in between. But of course, you will not start the discussion like let x be a variable in this state and this and that. You will just simply say the main points. So that's why being logical is not the only desirable thing. Sometimes we can be illogical also, or rather not illogical but informal. So this is the thing, but we have to be absolutely sure about whether an argument presented to us or presented by us to someone is informal or logical. Because while informal discussion is helpful, once you try to write down a proof, a mathematical proof, you are supposed to be logical. Every step should have a reason. Okay. Now this is a skill. Actually, it's a skill. In writing logically is a skill that has to be learned like any other skill. For example, you learn to swim or to dance in some dance form. But the thing is that logic is also innate to us. It is inside of us. In fact, in our everyday life, we use the logical rules, the laws of logic, which are quite simple. For example, if you are going outside and it's raining, you take an umbrella with you or you take a raincoat with you. So these are logical, these are principles of logic that we use. Now the thing is, because logic is inside of us, so the laws of logic we will quickly come across this. Laws of logic should make sense. Now this making sense, this part I should explain properly. Now what makes sense is something that we are familiar with. For example, if I release this marker pen, it will drop, right? It will go down. It will not go up, it does not go up. In ordinary normal situations, this goes down. And even if someone has not studied about physics or Newton's laws, that person can also tell you that in normal situation, things go down when released. So that is common sense, that it makes sense for the object to fall. But that is a real life situation. In mathematics, as opposed to real life, we deal with abstract concepts, numbers, functions, vectors, things like that. So we have to use the laws of logic carefully there. But still, the laws of logic themselves should make sense. If you come across a law of logic and you really don't understand why it is true, then that is a problem. I mean, then you have to rectify that problem. You will not be able to use that law of logic correctly in mathematical situations. So that's why the laws of logic make sense. Now this, however, there is something that I should point out here. Not all the laws make sense to the same extent. There are some laws which may even appear wrong. We will discuss about them at length. So let us just go forward and start the thing. So this was the initial